Welcome on our lecture series in wireless mobile communications. Uh, today we have the topic about the introduction to small scale fading. Uh, the definitions of this small scale fading, we are know that the small scale fading, or we can say it is the simple fading, is used to describe the rapid fluctuations of the amplitude and the phase over a short period of time or travel distance. So fading shows fluctuation on receiver and random variation in received signal is called the fading. Why it is? Because it is the caused by the variation in height and density of the ionization. So fading is also produced by interference of two waves variation in a few dB. So we can say uh, fading also occur when there is a change also there is a change in the path of the trajectory of the propagating signals due to some specific environmental effects. The specific environmental effects are nothing but it is this surrounding effect, that is the long trees, buildings, mountains, lampposts, and other phenomena like rains, wind blows, etc. So this is cause the deviate your signals which are actually propagating in the free space uh, medium. So the waves are get affected by this natural phenomena. So we are not getting the any signal at the other ends, and this is nothing but it is the cause of the fading effect. Actually fading is normally variation in not only in the terms of attenuations but also in terms of the time delay. So in the previous lectures we already seen how this is thing is occur in multipath propagations. Now dealing in other ways, we are see how we start from the initial point, yeah, initial stage of this fading topics. So consider there is a earth surface, like it is in a curvature form, and it is shown like this way. It is our earth, and we are putting the transmitter at here. This is the transmitter end, and we are putting the receiver and at here. If you can say it is the in the line of sight, there is the no problem. It can be reached easily in the receiver end, but the in an atmospheric environmental, there are a certain layers which are present in our in this earth environment. Above from the surface of the earth, around 16 16 kilometer, uh, it is about distance which is 16 kilometer. There is a one layer. That layer is known as tropospheric. Tropospheric. This tropospheric layer is present just above of the 16 kilometer. From the around from the earth surface. If we move in a space, it is around 50 to 400 kilometer distances, 50 to 4 kilometer 400, sorry, 400 kilometer. We are found another layer. That layer is nothing but it is the ionization layer. It is also known as ionospheric layer. Ionospheric layer. So if we are targeting how the multipath actually taking place. So this transmitter transmit these signals, and that signal is fed on the tropospheric, and then it goes to another end, that is the receiver end. This is this single path, and here we described this is the first signals. After that, it send the signals which is lies on a surface of the this ionospheric sphere. Ionospheric is coming here, and it received by the receiver after the reflections. That is the second signal. Actually, transmitter transmit this signal in all the directions. So it also transmit these signals in a short wavelength like this, and it fell on the surface of the earth, reflected back, and again strike on the tropospheric, where is the some reflection is taking place, and after they are reaching at the end of the receiver end. So this is the actual trajectory which follows the third third signals. So the signal actually, if we write the how much the signal is strength is calculated. So signal strength is calculated 20 10 to 20 dB. Signal strength strength in calculated in dB, 10 to 20 dB. So how this is look like, it is the signal which is reaching at receiver end, and there is a multi-path signals, the multi-path components of the signals. So we taking the vector sum of all these signals. So vector sum of this signal is nothing but first signal, second signals, and the third signals. So this is all about the signal is reaching at in a multi path propagations. So it follows the multipath propagations. So due to interference of the two waves variation in a few dBs, so fading is taking place. So if we are talking about the how the this fading is taking actually how the large scale fading and the small scale fading, what is the difference between this, and why the factor influencing the small scale feeding. Now we see how much the factors influencing the small scale feeding in a multipath propagations. So factor influencing in small scale feeding, small scale feeding. That is the multipath propagation. It is the multipath propagation. So you already seen there is a reflections presence in the path of the objects in the form of objects when the waves are propagating, and scattering is also taking place in this propagating medium, or you can say the channels. So the this propagation multipath propagations are get effective, and they are seen in the other parameters. So the presence of reflection objects and the scattering natures in the channels, they are creates a continuously changing the environments, so that the effect the signals in terms of amplitudes, phase and time. So if we see presence of reflections and reflection objects and scattering and scatters scatters in the channel channel creates a creates a constantly changing environment, changing environment that that affect your that affect the signals affects the signal in terms of amplitude, comma, phase and time. So it leaves the situation that is in the receiver that could your received the multiple copies of the transmitted waves that have different phase, time of arrival, and create the signal that means is degrading the quality of the your signals. So if you see these multiple components are receiving at your receiver. So this is the transmitted multiple copy transmitted multiple copies, and due to have a different phase. So due to different phase and time arrival. Why? Because they are traveling in a different location, and they are covering the different distances. So it degrades your quality of the signals. So it is important to have a speed to know about the speed of your mobile. So another thing is speed of mobile. So first is the relative motion between your base station and the mobile station, which is actually in your in a car, that results that it is moving either this direction, or you can say in this directions. So what the effect of this? Because if they are moving, so it results in random frequency modulation frequency modulation due to the Doppler shift on each of the multi-path component. So it causes the some factors which is influencing your small scale fading, and that factor is seen in a terms of when the signal are started to transmit in a free space. That is the power of your transmitter and the time at which they are receiving. So you can see in this diagram, the signal is started when it is transmitted. There is no obstacle in between. After the different path of environmental effects, they are actually changes their phases. So it is quite nature that our system is are affected by the small scale fading in terms of multipath fadings. So you can see the diagram. There are transmit power and the received power in a y directions, in a y axis, and at the uh, x-axis the separation distance between the transmitter and receiver are shown. So you have seen the blue light that is shown the large scale fading. This is the large scale fading, and you also seen the there is a medium scale shadowing effect in terms of during the propagations of the in a free space model. But you also seen that there is a multi-path fading which is occur like this way, and you are seeing the fading effect is just from this drop line. This is the fading. It is just due to power of transmitter and separation distance between the receiver and in between the specific environmental effects. So uh, this is started when the it takes the long time, then the slow fading is taking place, and when it is the occurring the small time durations, and the buildings, the trees, other phenomena, those fast fading is are taking in this short durations time. And there is also in a deep fade, there is a very slow fading is also occur during the transmission of your signals in a wireless communication. So it is quite important to see how the our speed of the transmitter or speed of your receiver and is get affected by the specific environmental surrounding environment effects. So the speed of the surrounding objects is the first influence factor. So we are right here. I'm going to write speed of the surrounding objects. So, if the object in a radio channel are in motion, they include the time varying Doppler shift on the multipath components like this. There is a track, railway track, and your trains are actually arriving your station. So in this if the object of this uh, radio channel in motion, we are in motions, and they include the time varying when it near to stations. The Doppler shift on the multiple components are effective by the two means. First is the movement of your surrounding, and this is uh, seen large when the mobile users uh, are there. So it create the some equations. So movement of your surrounding is large as compared to the mobile user user then fading is taking place. Then you get the fading. And second is again movement of your surrounding is less than as the mobile user. In that case it is ignored. And B case, another type of case is the transmission bandwidth of your signal. Transmission bandwidth of the signal in this category is the bandwidth of this signal. If the bandwidth of the signal is larger at the bandwidth of the channel, bandwidth of the channel in that case two things happen. First is, of course, signal is affected, and it is affected, not only affected, but it is rapidly affected. Signal is affected rapidly, and simmering is also taking place. Simmering is also be not only taking place, but it will also be high. And second is the bandwidth of your signal bandwidth of the signal is less than the bandwidth of the channel, bandwidth of the channel, then fading is then fading is not significant. Now we move towards multipath and the fading topic. And what is our conclusion under this heading? Now see, first conclusion is the wireless transmitter and wireless environment 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 channel. It is the free space path. You can write this. The other end is receiver. So you are able to say that the wireless channel is a multi-path propagation channel. So now we are going to write a wireless channel is a multi-path propagation channel. Now the second thing is why this is multi-path are seen in your wireless communication, because these are the rapid fluctuation of signals in terms of amplitude. So it is in a small time travel, small distance. So it is the called small scale fading. Multipath that is rapid fluctuation of the signal amplitude amplitude. So it is the small scale and another is caused by the destructive interference of two or more versions of the transmitted signals arriving at the receiver at slightly different times. So the in the case of this, it is with a different having a different amplitudes and also having a different phase. So we are going to write cause by destructive destructive interference interference of two or more more version of versions of the transmitted signal transmitted signal arriving at the receiver at at, at the different time with different amplitude and phase. With the different amplitude amplitude and phase. So signals may uh, come from at the receiver, and that is you can say it is the our next point. So signals may come from from different different direction different directions, or you say with the different propagation delay different propagation propagation delays. It is in random in nature. Okay, so the it also having this signal is also having with a different amplitude, and they having different amplitude when they arrive at the receiver end. That is also in random. Random with phases that is also random, and last with different phase means with the different angle of different angle. So this multipath signals are combined as a vector sums. So it is the fade distort this multipath combined vectorial sum, and it indicate the fad a distort So the channel behavior of like a random, it is our duty to predict uh, uh, at what time it's dynamic and what time is static. So channel behavior like a random. So this is the channel transmitter and this receiver. So our mean is, first of all we prediction, then we go to scene, it is dynamic or static. Another point is, describe the rapid fluctuation of amplitude of the radio signals over a short period of time or a travel distance. The large scale path loss effect may be ignored. Questions are arises why we are not taking in this small scale feeding the rapid rapid fluctuation of the amplitude of the radio signal radio signal over a short period of time period of time or 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 travel distance and large scale feeding is ignored. Large scale path loss effects may be ignored. And another point is the fading is the caused by the interference between two or more versions of transmitted signal arrival at the slightly different time. So the combined at the receiver antenna to give a resultant signal which is vary in the amplitude and the phase. Combined at the receiver antenna to give a resultant signals which vary in amplitude and phase depending on the on the on the distribution of the intensity intensity and relative relative propagation propagation time of the of, of the wave and the bandwidth of the transmitted signal.